Okay, period 7, algebra. Sorry I can't be there today. It's Friday, February 19th. This video is going to show you how to do factoring by grouping, which we didn't get to on Wednesday. First of all, there's some pretty good examples in your book on pages 367 to 369, but I'm also going to do a few now. Hopefully this will actually help. Okay, first of all, factoring by grouping is only going to be for 4 or more terms. And there has to be an even number though, so it's either going to be 4 terms, 6 terms, 8 terms. I can't imagine that we would ever have more than 6 terms. An example of something that could be factored by grouping is AB plus 4A plus 7B plus 28. There's 4 terms there, so one of the things I'm going to try is I'm going to try factor by grouping. Okay, so we're going to factor this by grouping, and this is what this means. If you, first of all, you want to look at these 4 terms and ask yourself, do they all have something in common, which means, do they all have a greatest common factor? And they don't. They don't all have something in common. But if you take these 4 terms and you split them into the first 2 terms and the last 2 terms, and you ask yourself, do the 2 terms in front have anything in common? And do the last 2 terms have anything in common? They do. AB plus 4A, they have an A in common. So we're going to factor out the A, and we get, when I take an A out of those first 2 terms, I get B plus 4. On the last 2 terms, they have a positive 7 in common. So I'm going to factor out a positive 7. And what I have left inside is B plus 4. Now the reason why we did that was because now if you look at what's left here, this is technically a binomial because this is one term and this is the second term. Look at what they have in common. They both have a B plus 4 in common. This term has a B plus 4. This term has a B plus 4. So that's their common factor. So we're going to take a B plus 4 out. And what do we have left? We have an A plus 7. So that polynomial factored into B plus 4 times A plus 7. And the cool thing is you can actually check this. If I FOIL this, do binomial George, B times A is AB, 7 times B, the outer terms, is 7B, the inner terms, 4 times A is 4A, and 7 times 4 is 28. If I did this correctly, I should get back exactly what I had in the top problem. Now, you will notice it's not in the same order, and that's okay if it's not in the same order, but it is the same polynomial. So this actual polynomial factored by grouping is B plus 4 times A plus 7. Okay, now we're going to try to factor this polynomial. Okay, again, the first thing you ask yourself is, do all 4 terms have anything in common? And the answer is no. So we're going to look at this in split groups. We're going to look at the first 2 terms, and we're going to look at the last 2 terms. Notice I also underline the negative in front of the 4. 2xy plus 5y squared. What do those 2 have in common? Well, they have a y. So I'm going to factor out a y, and what I have left is 2x plus 5y. Now, if you look at the next 2 terms, negative 4x minus 10y, what do they have in common? Well, they both are negative, and they both have a 2. So I have a negative 2 in common. So when I factor that out, I get negative 4x divided by negative 2 is 2x. Negative 10y divided by negative 2 is positive 5y. Now, here's the key to factoring by grouping. If, when you get to this point right here, if my 2 terms are not the same, if I don't have something in common now, I know I've done something wrong, because otherwise it's not going to go ahead and factor by grouping. So now notice both of these have 2x plus 5y in common, so I factor out 2x plus 5y, and I'm left with y minus 2. And that's that answer factored by grouping. Okay, here's our next one that we're going to factor by grouping. Okay, first thing, we're going to look and see, do they have anything in common, all four terms? The answer is no. Now, you need to know, eventually it's going to be a yes. So if I split these into two parts, there's one part, here's the second part. The first two terms have what in common? Well, they have an x. So I'm going to factor out an x, and I get 3x plus 4y in common. Now, if you look at the last two terms, it appears they have nothing in common, right? But notice that right here I had 3x plus 4y. That is 3x plus 4y. So I can factor out what out of the second section so that this is my common term. 3x plus 4y, they do have a greatest common factor. We've talked about this. It's a 1. So we're going to put plus 1 here. And then when I factor out a 1, I get 3x plus 4y. Okay, I know that's a little weird on that one. So now, if you notice, what do they both have in common? 3x plus 4y. And what's left? X plus 1 when you take that out. Okay, here's the next one. All right, this one's a little different also. All right, so if I look at these four terms, they don't have anything in common. And here's the problem. If I look at these two terms and I split it with these two terms, 3xy minus 4, they still have nothing in common. X minus 12y still have nothing in common. So it looks like right now that we can't do anything, but that's not true. The other thing you can do in factor by grouping is if you switch the two middle terms, sometimes that actually helps. So if I take and I rewrite this problem as 3xy plus x minus 4 minus 12y, let's see what that did. Okay, so now if you look at the first two terms and you look at the last two terms, now do they have stuff in common? And the answer is yes. 3xy plus x has an x in common, and we get a 3y plus 1 when we factor out the x. Negative 4 minus 12y, what do they have in common? They have a negative 4 in common. So I take out the negative 4, and what do I have left? I have 1 plus 3y. Now, when I did this, look what I have that's common. Is 3y plus 1 the same as 1 plus 3y? Even though they're not in the same order, they are the same thing, which means these two have a common vector of 3y plus 1, and we have x minus 4 left. Some of these get a little tricky, as you can see. Okay, here's our next one. All right, remember how I told you the first thing you always look for is to see if all four terms have something in common? And so far they haven't. Well, now they do. What do all four of these have in common? They have a 2 in common. So we need to factor out a 2 before we can ever even think about grouping. So we're going to take the GCF out of a 2, and what do we get? We get 2ax minus 2ab minus bx plus b squared. You have to do that first. All right, so now what? All right, so we don't even worry about that 2 on the outside for right now. Now we're going to look at the four terms that are on the inside, and we're going to ask ourselves, can we do any factoring out? All right, so I'm going to keep carrying down my 2. 2ax minus 2ab, what do they have in common? They have a 2a. So I'm going to factor out a 2a, and I get x minus b left. And then on negative bx plus b squared, I'm going to take out a negative b. And the reason why I'm going to take out a negative b is because if you look at the first one that we had over here, I have an x minus b. I want a positive x. So to get a positive x, I have to factor out that negative out of the first term. So if I take a negative b out, I have x minus b left on the inside. If you wouldn't have taken out the negative b, you would have taken out a positive b, then what's going to happen is our two terms right here, x minus b, would not have been the same. You would have had to figure out to take out a negative 1. Okay, so now I have an x minus b in common. So my final answer is 2, because that's the 2 that we came out very beginning. And then I have my common factor of x minus b. And then if I take the x minus b out, I still have a 2a minus b left. And that is my final answer. All right, let's do one more, and then you should hopefully be okay to be able to do your homework. All right, so ask yourself, is there anything these all have in common? And the answer is yes. They all have a 2 in common. So I'm going to take out a 2, and I get 12x squared. Nope, sorry, I don't get 12x squared. I forgot to take the 2 out. I get a 6x squared, y, minus 21x squared, minus 2y, plus 7. All right, so I took out the GCF. All right, so now the next thing we're going to do is we're going to see, is there anything that the first two terms have in common and the last two terms have in common? Okay, so let's try it. It looks like the last two aren't going to have anything in common, but we'll see. 6x squared y minus 21x squared. What do they have in common? They have a 3x squared in common. And we're going to pull that out, and we get 2y, and we get minus 7. Okay, so look at that. That's 2y minus 7, and over here I have negative 2y plus 7. Those are almost the same. They're completely the opposite. So what could I take out of negative 2y plus 7 to get a 2y minus 7? What I'd have to factor out is a negative 1. Because if I do, then I get negative 2y divided by negative 1 is 2y. 7 divided by negative 1 is negative 7. So here's where I'm at. All right. So these have a 2y minus 7 in common. So my final answer is 2 times 2y minus 7 times 3x squared minus 1. Okay, so now what you are doing tonight for homework is, or over the weekend, you are going to do page 370 in your book. You're doing page 370, 56 to 86 evens. All right, good luck, and I'm still not going to see you guys until Tuesday because I'm out Monday. So there will be another video that you guys will have to watch on Monday. Have a good weekend, and I'll see you guys later.